All right, let's get into page 2 of the study guide. So, first part of page 2, problem number 9. What is the first step when algebraically finding the inverse of a function? First step is going to be to switch, swap, exchange, however you want to say it, but switch the x and y variables. That's the whole purpose of an inverse, is you switch the x's and y's. All right, so problem number 10, determine the equation for the inverse of the function. So right now, the g of x is your y variable. So if you wanted to, you could write y right over it. So now that we know that we need to switch x and y, where I have an x, I'm going to write a y, so 6y plus 2. And where I have a y, I'm going to replace it with x. That's step 1. Step 2 is now going to be to get this y variable all by itself. I want to isolate y. So to do that, in this case, I'm going to subtract 2 from both sides. So x minus 2 is equal to 6. That's a horrible 6. 6y. And then the last step here is going to be divide both sides by 6. So we're going to end up with the inverse y function. So y to the negative 1. So the inverse y is equal to x minus 2 over 6. The fraction goes over everything. You do not need to simplify anything because there's really nothing to simplify there. So let it be what it is. All right, I'm going to slide over to number 11, and we're going to repeat the process. Determine the equation for the inverse of the function j of x. So j of x here is going to be my y variable. Where I have y, replace it with an x. This is going to be the fifth root of y minus 2 plus 1. And I want to get this y completely isolated. So a couple of different ways to do this. You basically want to start peeling away the stuff around it, but you also need to make sure you're doing it in the right order. So if it helps, off to the side, you might want to write down the order of operations for what you'd have to do for y right now. So y right now, you'd need to subtract 2. So I'll just do minus 2. You would need to then do the fifth root. So I'll put a little fifth root symbol. And then I would add 1 following my order of operations. If this helps you, what you're going to do now is start at the bottom of the list and work your way up. So the very first thing I actually want to do is get rid of a plus 1. So I'm going to subtract 1 from both sides. So plus 1 minus 1 cancel. I get x minus 1 is equal to the fifth root of y minus 2. So that part's now done. If I then look at my next step, how do I undo a fifth root? Well, every root has an inverse power that I can use. So fifth root would be the inverse power of the power of 5. Now, on the left side here, x minus 1 to the fifth, do not multiply that out. Just let it be x minus 1 to the fifth. On the right side, fifth power and fifth root cancel. I get y minus 2. Fifth root's done. Last step here is what's still attached to y is a minus 2. So I'm going to go ahead and add 2 to both sides. So the inverse of y is equal to x minus 1 to the fifth plus 2, and that is the inverse function. Now, it doesn't particularly matter if you put y equals or the function equals y. That order won't matter. So we got y all by itself, and we now have problem number 10, and we know the inverse. All right, problem number 12, still doing the same work here. Where I have a y, replace it with an x. Where I have an x, we're going to replace it with a y. My job is to get y by itself. So first thing I notice is that I have a 7 over 2 times y. The easiest way to get rid of multiplying by 7 over 2 is to actually multiply by the reciprocal. Remember, reciprocal is just a big word that means flip the fraction over. But what I do to one side, you got to do to the other. So I'm going to do times 2 over 7 here. So 2 over 7x is equal to now 7 over 2 times 2 over 7. If you multiplied those out, they would turn into 1. So I would just have 1y cubed, or just y cubed. I still need to get rid of the power of 3 here. So I'm going to go ahead and take the cube root of both sides, right? Every power has an inverse root. So cube and cube root cancel. So the inverse of y is equal to the cube root of 2 over 7 times x. Now, the 2 over 7 and the x, all of this is inside the square root, so make sure your square root extends over everything and includes all of the pieces. All right, last one in the inverse section here is problem number 13. Algebraically determine the inverse of that function. So my y variable is where we've got f of x. So where I have a y, I'm going to replace it with x. 2 times the 4th root of y minus 3. If you want to do the little list of steps, that's fine. If you can look at it and figure it out, that works too. The list of steps here, remembering that we are trying to get y by itself. Here's y. Order of operations here would tell me to subtract 3 first. I would do a 4th root. And then I've got multiply by 2. I'm just using a little x for multiplication. So I want to undo those steps in reverse. So how do I undo times by 2? Well, I need to divide both sides by 2. So I'm going to have x over 2 equals the 4th root of y minus 3. How do I undo a 4th root? Well, I'm going to use its inverse power, and the inverse power to a 4th root is a power of 4. So 4th root and 4 cancel, and that just leaves me with y minus 3. And this is another place. Do not multiply this out. You don't need to. In fact, I don't want you to. All right. Last step here is how to get rid of a minus 3. So I'm going to add 3 to both sides. So I've got x over 2 to the 4th. Let that be the fraction that it is and the power that it is, plus 3 equals the inverse of y. So that is my new inverse function. I have taken care of everything to get y all by itself. So that's all the inverses. The second part of the page is transformations and describing them. So let me drop on into problem number 14, part A. Right here is my transformation. That is a vertical shift or vertical translation. And because it's minus, it's going to be down 9. Problem part B, instead of having the minus sign on the outside, having it on the inside means that this is going to be a horizontal translation. And this one is opposite to what you think it would be. It's actually going to move you to the right 9 units. Part C, we've got again another function where we are adding something to the entire radical. So we've got the square root of x as one entity, and then we've got a plus 3. So that plus 3 is going to be a vertical translation. Positive 3 is going to be up 3. That's straightforward. It's kind of nice. Last one here, if we've got the plus 3 inside the radical attached to x, this is going to be a horizontal translation. And that is going to be left 3 units. Okay. So vertical is outside of the radical, horizontal is inside of the radical. Vertical is pretty straightforward. If it's positive, we're moving up. If it's negative, we're moving down. The horizontal ones are kind of opposite to what you think they would be. Okay. All right, so let's get on down into problem number 15. The original function is the cube root of x. I can already tell you there is a small mistake here. I will fix it before I post the key. This should be a cube root as well. Changing the root is not a transformation. That's a total function change. So we don't want that. So for problem number 15, what do we have as changes? Let's see, we've got a negative in front. So that is going to be a reflection over the x-axis. Because we're adding 2 to x, that is a horizontal translation. And because it is plus 2, it's actually going to be kind of reverse of what you think. So it's actually going to be to the left 2 units. All right, so 15's done. Number 16, yeah, you need to make sure that this root and this root match. That's a good thing here. So that 3 in front is going to be a vertical stretch by 3. So we're making this graph 3 times as farther away from the x-axis. We're stretching it away. Minus 5 attached to x is going to be a horizontal translation down. Whoops, I don't know why I just said down. Hold on a second. That's actually to the right 5. Sorry about that. And the last one here is going to be this plus 2 outside of the, in this case, cube root, outside of the radical. That is going to be a vertical translation. Vertical translations are straightforward, so that's going to be up 2. All right, 2 more problems here. Problem number 17, we want to write a function that has been translated to the right 3 and up 2. So when we go to write this function, I don't want to use the same notation. F of x has been defined as the square root of x, so I don't want to use the f of x notation. You can use any other function notation you want. I'm just going to go with g of x. All right, so there's the original function. If we are translating, sorry about that, if we're translating to the right 3, I want to do x minus 3. That would push me to the right. And up 2 is actually going to be plus 2 attached to the whole radical here outside. So that is the new function that's been translated to the right 3 and up 2. And last but not least, problem number 18 here. What nifty little things do we need to do? We want a reflection over the x-axis. We want it translated to the left 9 and down 7. All right, again, I don't want to use the same parent function notation, so f of x. In this case, I'll use h of x. Doesn't really matter, but you just don't want to use f of x again. All right, reflection over the x-axis means we're going to have a negative in front of the square root. Inside the square root, to move us to the left 9 units, we want to do x plus 9. And to move down 7 units, we're going to do minus 7 outside of the radical after it's already been done. So those 3 transformations will take care of the reflection, shifting to the left and down 7 units. So this particular page was all about finding those inverses algebraically and then all about transformations. If you have any questions or concerns, please let me know.